Hey guys, I'm Pat Kelly. Okay, in this problem, in this group of problems, they're going to give us a differential equation that will look something like this. And they're also going to give us a solution to the homogeneous version of that differential equation. And you can see those two particulars that they gave me in this problem. Here's my differential equation, and here's my solution to the homogeneous version of that. And what the directions tell us to do is to find a suitable y sub p given this information, specifically the y sub h that they give you. Okay, so here's what we're going to do. In order to start with your y sub p, the solution to your particular, or the particular solution to your differential equation, what you need to do is look at your capital F of x. So my capital F of x in this problem equals that 4 plus sine of x. Okay. And then from that, you make a guess at what you think y sub p is going to be, an educated guess, so certainly not random. But in this case, I would guess, and I have to be a little bit vague at first, I would guess, based on this capital F of x, I would guess that my particular solution would equal capital A plus capital B times sine of x plus capital C times cosine of x. All right, even explain that a little bit. Also, the directions did say to explain your reasoning, so you want to make sure that you can talk through this type of process. Explain it to yourself, explain it to a friend who's having trouble. All right, so to explain this, the way you set up your y sub p from your capital F of x, I'm going to grab some colors for some color coding, is mine actually has like two components. I do have this 4, just a lonely little 4 there, but I view that as a polynomial of degree 0, and I have to match that. This is also a polynomial of degree 0, but I have to keep it as generic as possible. So capital A, and I'd have to figure out what A did actually equal in my problem, if they wanted me to. That's something else you might catch in the directions for this problem, is they said you don't need to solve the actual differential equation. So, okay, so this capital A came from the fact that there's just a constant up here. And also, up here in my capital F, there was this trig, specifically a sine, and specifically the argument of sine was just lonely old x. That's what told me to set this part of my y sub p up. All of that, because what I'm trying to do is keep it generic again with my coefficients, and I also want to make sure that my arguments match what was up here. And this is my attempt to make the sine of x as generic as possible once it starts cycling through your derivatives with your y and your y double prime. Okay, so this is all good, but, and this is the key part of this problem, this group of problems, when you go to get your y sub p, it's important that there's no overlap with your y sub h, okay? And I have overlap here. Let's see if I can grab another color like orange, I guess. Okay, I'm trying to see something I don't have here yet, because I want you to notice the overlap here is the constant also shows up right there. There's a constant. There's no overlap with the exponential part of our y sub h, and also there's no overlap with the trigonometric part of our y sub p. So this is my concern. We easily get over that concern by multiplying any overlap in your y sub p solution by x. That's it. So my y sub p, noticing that there's that overlap, my y sub p will equal, I'm only worried about that a in terms of the overlap, so I only multiply that by the x that I just mentioned, and everything else is still there and stays the same. B sine of x plus c cosine of x. And that's it. Okay? So the trick with these problems is they give you y sub h, you come up with what you think would be a good y sub p, but then look for overlap. If you see overlap, multiply in your y sub p by x. Okay? I hope that helps with this one. Practice some more on your own.